Alright, good evening everybody. Good evening once again. So, we will be doing some questions. Let us do, 15 minutes of databases. Alright, I don't know how many minutes I have on the databases, but let's do that. So, where are we? We did this. I don't, nope, not this. Previous gate, yeah. That is what I have been saying. Okay. Did we do this one? No, we did not do this one. We did this one. No, wait, what? We skipped a few questions, it seems. Did we skip a few questions? We did this. Conflict serializability. Relational schema. Okay. Something's not popping. Audit, we did the audit one. We were stuck at that, and the functional dependencies, yeah. This one. Yeah, we did not do many questions of DBMS. Because yesterday was programming in data structures, so you can do a lot of them. So you need to keep a track actually. So you need to. Wow, that is a scratch. Okay, that's 11. I guess we did total 36 questions and a few TOC questions. Alright. So the thing is, right. Let's have an analysis. So engineering mathematics. So discrete maths. How many questions of discrete math did you solve? We did everything of 2025. Okay, we were at Lucas series. Yeah, I guess we did all of 2024 and 2025 of discrete mathematics. Yeah, that's a lot. Okay, so where should I write this? Progress. Let's put it all the way at the top. Discrete math. Let's solve year wise, people. 2025 and 24. That is correct. And we did not do any of this, don't worry. So, in the digital logic, multiplexer, yeah, we did this one as well. Yep, we did this one as well. Yeah, I guess we stopped here over here. Let's put 20, 25, and 24. Yeah, we did a lot of this if I'm not wrong. Yeah, we did this one, a by 2 plus 1. I thought it was a by 13. I did this one as well. That was the winter 2023. Note that. Yep, we did this one. I guess we just completed 2023. And regarding the algorithms, Yeah, we stumbled over here. The number of edges present in the forest is generated by DFS. So, so 2024 algorithms. First page, first 20 questions. That makes a whole lot of sense. Wow, there are a lot of questions from TOC. Did we do all of 2025? So deterministic pushdown automation. Any regular language is accepted by it. Any regular language. Yeah, we did this, I remember. Yeah, we did this one as well. Like the entire state depends upon the number of ones. If number of ones are odd, then it will end up in the end state, and if the number of ones is even, it will end up over here. So 0 star 1, and that is mandatory 1, and 0 plus 101. Okay, 1, okay. So 0, 1 plus 0, wait, 0, 1 plus 0, 1 is not an example. 0, 1, 1 is not an example of that. So A is your answer, right? Yeah, we did that one. But TOC, let's put it as 2025. Yeah. And comparison, let's skip that. And operating systems. We did not do semaphores. Under 25 set to all right. How is it that we are able to solve? Okay, it is repeated. An optimal page replacement algorithm. Yeah, we did not even complete 2025. Okay, just one question for 2025. I see. We are going to look at that. Ouch. 1, 2, 3, 4, 5, 6 subjects. Then So optimal page replacement algorithm information about all future page references is available to the OS. A modification to the optimal page replacement is as follows. The OS currently predicts up to only next page for references including the current page. At the time of getting a framed or page, the processor accepts the pages in the order of page numbers. Okay, if a system has three memory frames that are initially empty, the number of page faults that will occur during execution the process is. So it is optimal. So it is going to know for the next three steps. I have done this question by the way. 1 3 2 4 2 3 1 2 4 3 1 and 4. So initially it is empty. 1 will cause a page fault and 1 3 will cause a page fault. 1 3 2 will cause a page fault. So at 2 it is going to know the information about 4 2 and 3. So 4 2 is needed, 3 is needed, so 1 is not needed. So 4 is a page fault. 3 and 2, 1 will be replaced. So now you are going to need, okay, you are currently pointing here. Let's remove this. You are currently here. All right. So 2, 3 and 1. So is that how that works? 2, 3 and 1. So 4 is not needed. And 3, 1 and 2. Okay. All of them are needed. It will point here 1, 2 and 4. 1, 2, 4. So 3 is not needed. So 2, 4, 3. No, I don't think that's how that works. 4, 3, 1. But it always looks ahead, right? Exactly. 1, 3. Yeah, so 1, 3, 1, 3, 2, 4, 3, 2. Alright. Means OS configuration of page replay. 413.9. Okay. So it won't replace a page, I see. During base fault. We will replace to minimize. Okay, getting further page faults. We won't look ahead like we did over here. So let's write this one again. 1, 3, 2, 4, 2, 3, 1, 2, 4, 3, 1, 4. So 1, that's a base fault, and 1, 3, that's another base fault. 1, 3, 2, that is another base fault, and 4. So frames are full, and based on 4, 2, and 3, 4, 2, and 3. So 1 can be replaced, that is another base fault, and 2, 3, 1. 2 is present, 3 is present, and 1 is not present. So which page needs to be replaced? 1. Okay. 1, 2, 4. Out of these, 4 needs to be replaced. Yeah, because you are going to need 2 in the next run. 4. So 2, 3, 1, that is another base fault. And 2, 3, 1, okay. And now regarding 4. So 4, 3, 1. 1 is there. So yeah. 2, 3, and 4 again a base fault. And 2, 3, 4. Oh, 1, 2, 3, 4, 5, 6. No, what the heck are you doing, my guy? There is no 1 here again. One, two, three, and 4, and 5, and 6, and 7. What the heck? Two, 1, 4. Why did you replace with 4, my guy? Very good. 2, 1, 4. 2, 1, 4. Okay. And again, you now need 3, 3, 1, 4. You have any unnecessary one. So you got 1 and 4, and 2 is not needed in 3, 1, 4. So 3 should be alright. So 3, 1, 4. That is another base one. 3, 1, 4. 3, 1, 4. So that is 1, 2, 3, and 4 base faults here. 4 base faults. There is 5 somewhere over here and 6 here. Oh my god. So why did we do this? Just to say we completed 2025 operating systems. 2025. And where are we now? We are at DVMS. That is my second time doing it. Oh my god. Conflict serializability, B plus tree, and audit. And we did functional dependencies, three databases. We were yet to do 1 and 2 and 3 and 4 and 5 questions to complete both the set 1 and set 2 of 2025. So how many did we do? 1, 2, 3, 4, 5 and 6. Sorry, we did 5 questions. We did 5 questions. That's it, okay. Read and write. So R1 of x, W1 of y, R2 of x, R2 of y, R3 of y, and about T1. Which of the transactions will be rolled back? So T1 is aborted. So R1 of x is invalid. So R2 needs rollback and W1 of y is invalid. So rolls back both T2 and T3. Yay, I did it. Oh my god. So 9:15 it is, and we will complete databases. And after databases, we will let's have an idea. So I think we will still have 1.5 hour, or maybe in 15 minutes. All right. After databases, we'll try to complete the save on organization and computer networks. That is one iteration. That's it. That's it. Really. Can you do questions like this in SQL 92, which is what gate assumes? Which columns are allowed in select and having? Which columns are allowed in select and having when group by is present or not? I don't know. That is just a query. Ask 11 days ago. Okay, 1 day ago, I think. Consider an instance. Okay, we should do this. I mean, just we are doing it as a hobby. So Select s dot name from the aliases. We are selecting the names where s dot rating is greater than any. Alright. S1 dot rating from sailors. Alright. Age less than 21. So Jones and Moby has age less than 21, and S1 dot rating is greater than, okay, greater than the rating of these two people. So Moby's rating is 6 and Jones rating is 3. Any means all iteration, so greater than 6 and 3, that is only 7. So Ahab, A is your answer. Ahab. What? Okay, that's false. That is a wrong interpretation. In addition to an operator, any. Okay. Yeah, any misinterpreted the meaning. So you just need to practice, that's it. A relation ABC in which the functional dependencies can take 20 distinct values. Okay. What is the maximum number of possible size in self-join? Avid reader. Okay. Self-join. Okay, I don't know about that one though. Uh-huh. 2023 it was not changed. Eighteenth of January, okay. The last All India mock test was done. Uh-huh. Okay, anyways, we have enough things. Anyways, I feel like we're wasting time. We did this one, right? Yeah, we did this one. Okay. B plus trace with 5 nodes and all. A node can store at most 3 key values. Value 23, okay. So 20, alright. 6, 12, 19, 1, 4, 3, 7, 9, 10, 13, 15, 17, 22, 23. So you need to split it. So 20, 21. What will split? Maybe you can push it. 21 is going up. And it will become 20, 21. 22, 23. But you need to push that one as well. So 12, let's do that. 6, 19, 21. And 1, 4, 3. So 7, 9, 10. 13, 15, 17. 20, 21, 22, 23. Height increases, that is correct. The total number of nodes remains same, that is false. At least one node will split, okay. B and D. Accurately do not split here. Okay, if you send that one, then okay. Yeah, that is making a whole lot of sense. Team name, alright. TID, teams TID, team name, TID, team name, and TID and team name respectively. Okay, oh my god. Oh my god. Player ID, player name, and team ID. Which one of the following relational calculus queries written the name of the players voting for the team having names MI? P belonging to players and there exists T such that T belongs to teams and the player of team ID is equals to team.tid and team.tname is equals to mi. Okay. Who plays for the team? So P belongs to players. I mean, name of the players who play for the team. So P should not belong to players. Then it might not. Then it might return the players who does not are in a team as well. Okay, and P dot TID. Okay, the player dot team ID and team dot team ID should match. The player should belong to the team and the team should belong to there exists T such that okay B should be your answer. I don't know. So you are selecting every player. Oh wait, team should know. Okay, P name is not an attribute. Oh god. So guess you need to draw that. Teams and players. TID, T name, PID, P name, TID. Right. Yes. So P dot P name, where P belongs to players, selecting the name, there exists T such that T belongs to teams and P dot TID is equals to T dot TID. Okay, so these two are matching and T dot name is equals to mi. Okay, you need to select. Okay, if you wrote this one p dot p name where p belongs to player, or p, okay, p dot p name where p belongs to teams, there is no p name in teams. That is where we messed up. Okay, we need some analysis. A relational schema. Name, city, owner with functional dependencies. So name is basically the primary key and that is the candidate key. The relational team decomposes name city and name owner. It constitutes of a lossless join, that is correct. There are no transitive dependencies, so it is in 3NF, so this is false. T1 and T2 are in BC and F. Boys got normal form. I guess they are. B and C are your answers. Alright, B and C are your answers. A relation with two attributes is always BC and F, okay? So for every FT, BC and F requires X to be a super key. Any relation that is in B and F is automatically 3 and F, okay? Laggers. Okay. A decomposition is lossless if the common attributes, their common attributes, is a super key for at least one of them. Nice. Oh, what is this? Consider the following tables of Sport League. Okay, we did this, I guess. Select minimum age from player's age. Okay, where P dot PID in select M dot PID from team T, coach C members, and where C dot name is Mark. Okay, coach dot name is Mark, and T dot CID. C dot CID. What is the CID? 102. So who's having 102? This tuple and M dot PID. Okay, so you are selecting this tuple and M dot TID is equals to T dot TID. What is TID? 10. And who's having 10 here? 1 and 3. M dot PID. You are selecting this PID is 1, 3. The player IDs are 1, 3. And you are selecting the minimum age of those. Ishan. Ishan. Okay, and you are selecting the age, so 26. Yeah, this one dude. William A. Ward. No, that girl is. Yeah, I kind of loved that. I kind of want to, Google that. Can you search this image? Oh yeah. You had the same image somewhere. We did this one. Is that repeated? No, we repeated. Alright. We completed 2025 of DBMS. Guess that is enough. Oh my god. So, guess we will do another 15 minutes of Seaborn architecture. In a magnetic surface phenomenon, it chemical is stored in a consecutive sectors in the same triplet. Yeah, I don't know, man. Okay, so how many questions do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 questions. That's it. A computing system was with two levels of cache. Okay, in main memory, the first level access time is 1 nanosecond. Okay, and the hit rate is 90%. While the processor is accessing the data from L1 cache. 80% and the miss penalty is 10 nanoseconds. The miss penalty transferred from main memory to L2 cache is 100 nanoseconds. The average memory access time of the system. Oh my god. So there is L1 cache, there is L2 cache, and there is L3 cache. And this is so access time is 1 nanosecond with 90% hit rate. Just a second, alright. As for second level, the hit rate 80% and it is 10 nanoseconds. So, and obviously main memory, it will always be present in main memory and 100 nanoseconds. So the average memory access time is alright. Hit time plus miss rate into miss penalty. So 1 plus the miss rate is 0.1 times 10 plus and cascading 0.2 times 100. That's 1 plus and 0. Okay, we are doing something here. Okay, that is correct. पहला क्वेश्चन है धोखा दिया हमको. Yeah, the thing is, we have already studied all of this. That's our problem. I kind of like the last answer, actually. Yeah, we are correct. And that is hit rate plus miss rate times miss penalty. That's what we did, right? Cascading. Okay, that applies to whole, obviously. So there is only 10% of chance of going into that, and there is only 20% of chance into going that. So only 10% chance. It is basic math, dude. Only 20% of 10%. So there is 220. Alright, 31 plus 3, 4. Easy as that, as simple as that, and this is the best one. This is the best answer. If a high-stage instruction pipeline has delays, respectively, okay, and the delay in an interstage latch is 10 nanoseconds, assuming that there are no pipelines, knowledge data branches, and other hazards, the time taken to process 1,000 instructions. Nah, I have actually done this one. I didn't almost see that one. For integer type of questions, pay extra attention to the sign conversions or the okay, what do you say? The conversions of one scientific alright. What do you call it? I mean it is a number, so pay extra attention to the number. That's what I meant to say. And so these are stage delays. We didn't study that one to be honest. So stage delay max plus buffer delay. So buffer delay is 10 nanoseconds and the max is 250, so 260 nanoseconds. Okay, so instruction pipelining 5 stages. Mhm. I have read this one actually. Yeah, we are not usually. K stages, okay. But one instruction can advance only one stage per cycle. Clock must be slow enough. I want to keep it like this. K times TP fill time and minus 1 TP fill for first instruction. So K is 5 times 260 plus 999 times 260. Alright. So that is 1004 times 260. Where is our gate calculator? That is it, right? 10. So 261040 nanoseconds. Sorry, 10 power minus 9 seconds and 6 seconds. So this number will be 261.040 microseconds. Alright. Instructions at architecture. The clock frequency, the number of gears. Programmer visible. Hennessy. Okay. So we need to study some architecture. Yeah, I will take a break. That is easy question, at least. Direct mapped cache 4 bits or wow, computer organization contains a lot of questions. That is it. Consider a process with